Okay, question 101. So really the last question we did in the last video really highlights the meaning of the shadow price. The shadow price really is additional contribution, right? So the shadow price of skilled labor is currently $8 per hour. What does this mean? The cost of obtaining additional is £8 an hour? No. Just the cost of obtaining an additional hour of labor is just the cost of obtaining it. It's the cost of the raw material. There's a hidden cost of £8 for each hour. No. Contribution will be increased, yes, by £8 an hour for each extra hour of skilled labor that can be obtained. So it's very much about contribution. So the answer here is very clearly C. Okay, and question 102. Let's find the variable costs, and let's get the variable costs out first so we can get contribution. Right, so we have here 30 and 20, that's 50, which means the contribution, of course, here is 50. Here we have here 50 plus 35 is 85, so it's 85, so that means that contribution here is 65, because that's 150 minus 85. And then I have here, I'm going to use a calculator here, so I have here 25 plus 30 plus 22, so here it's 77, and therefore contribution is 83. So let's look at the time. So I ignore, of course, this fixed overhead. I focus on the time. I'm spending £20 an hour. It's £25 an hour, so my time is really 20 over 25. That in terms of time, so it's taking me, right, because if it's 25 pounds per hour and I've spent 20 hours, then I spent, if you like, less than an hour. So 20 divided by 25 here is 0.8. So that's the time spent here. I'll just use a different pen color. 0.8. 0.8. And then I've spent here 35. So I have here 35 over 25. Same thing. 35 divided by 25 here, and that's 1.4 hours. And here I've spent 30 over 25. And that's 1.2. So let's find out what's greatest if this is as a scarce resource. So 50 divided by 0.8 gives us 62.5. 65 divided by 1.4 gives us 46.42, and 83 divided by 1.2 gives us 69.16. So what is the most profitable? It must be T, 69.16, and the least profitable must be S, so T and S. Right, let's look at question 103. So what we see here is that we're given this linear programming model, and they've given us it for two products, X and Y. And this is the contribution function. And they tell us that each unit uses 2 kilograms of material Z, and each unit uses 3 kilograms of material Z. The standard cost is £2 per kilogram. They tell us what the shadow price is. They've worked it out for us. They tell us that additional contribution, every time you buy in 1 unit of this scarce resource, additional contribution is equal to £2.80. That is the meaning of shadow price. So in effect, if I'm going to bring in another 20 kilograms, I'm going to have additional contribution, therefore, of 20 times 2.8. So they give you all of this material to sort of trip you, make you think differently about what shadow pricing is. But shadow pricing literally is, what is the additional contribution? And that additional contribution, of course, is 20 times 2.8, which is an increase in 56. Right? Because 20, of course, times 2.8 is 56. So the answer here is B. Right, and let's look at 104. So they're telling us this organization is experiencing a shortage of resources and has graphed a potential linear programming solution, and it looks something like this. You have this thing here where you have TVs here at the far end. Imagine this is 10 TVs, and you have one tablet here. That's what they're telling you. Telling you that the curve itself is flat, is very flat and downward sloping. So it's pretty much saying that for the same amount of contribution, say for example, contribution was £100, you're selling one tablet, but you're selling 10 televisions, right? Because that's the ISO contribution line. That's how we determine it. If you like C is equal to tablet plus 10 TVs, so to speak. That's kind of your curve. Right, and we close out this first. We put our hand over this to know that if this was 100, therefore contribution here is 1, because I'm closing this. And then I have to find the contribution of televisions. I close out the TA, or the tablet, and then I find out that the TV is 10, because, right, I go T is equal to TA first, and then I go C is equal to 10 TV. That's how I find my extreme points, and then draw my line. So in effect, it means that the contribution from my tablets must be higher than for my television, and so the answer is A. But I think it's always a good idea to always put in some actual figures in to help you sort of arrive at the right answer. Right. So question 105. To be honest, I sort of did this by a process of elimination, because it took me a while to sort of just sit and just arrive at the final answer, but it took a bit of a while. But from an exam point of view, I probably would have gone from elimination. So I knew straight away that if I start manufacturing a product C, I cannot use a linear program on a two-dimensional curve where I have the units of one product, product A, the units of the second product, product B. And once you introduce a third product, I cannot do that on a linear curve. It says linear. If you like, I need to literally, I'm sure, of course, computers can do this, can factor this in. Of course they can. But I knew that would be tricky. So I knew this was definitely not an answer. JCO would not need to use linear programming if there was not a demand constraint. There are many other constraints. In fact, demand constraint is probably one. Demand constraints look like this, right? But we have other constraints. So this is not true. So I knew straight away the other two must be. But let's look at them. So the answers must therefore be these two. JCO should ignore fixed costs when making decisions. That's right. So we always ignore fixed costs in this whole analysis, pretty much looking at where variable costs, only variable costs, and there is the assumption that variable costs are constant, which is why I said I had to just think a second, give a few more, a minute at least, to just looking at this. It could be used when there is an experience curve, once steady state has been reached. And at steady state, you see, because when we come to talk about learning curves, we recognize that actually variable costs do change over experience. But when you do get to a steady state, variable costs remain constant as you make more units. So to a certain extent, we typically, these curves only work when variable costs are constant. Or variable costs equal to marginal costs are the same with the production of every additional unit. So in effect, this is correct, and this is correct. Right, let's look at 106. Another nice question. Let's just get rid of this. Oops, sorry. Let's get rid of this eraser. Okay. Yeah, let's use a green pen. So here's our contribution, 12A plus 8B, that they give to us. Although what they want from us really is the number of units that we need to produce in order to maximize contribution. So ultimately we need to, I think it's a good idea to always plot your curve. So you have these are your limited resources, material X, material Y. They've plotted the graph for you. So you can use this material to either make, it's in terms of plotting your graph, remember our graphs are always in units. We're always interested in the units. It's always about the units. So here I have product, I'm going to just choose and put product A here and put product B here. It doesn't matter. So I have 8,000 kilograms of this raw material. So with this, therefore, I can make, yes, of course, if I choose to make none of B, I could make 8,000 units, right? That's what I'm saying. I could make 8,000 units. So I will put I will put 8,000 over here. Or if I choose just to make B, I will make, because I need basically this 2 here is telling me I need 2 kilograms. If this is kilograms of material X, I need 2 kilograms per unit. Therefore, I can make 4,000 units of material B. That's what this is saying. So I can draw my curve here. And I'll change my pen color here to red. So material Y, here I can make, of course, 6,500 units of A, can't I? I can make 6,500 units of A if I only make A, or I can make 13,000 units of B. So I'm going to put 13,000 up here, and I'm going to draw this curve to look like that. Oh, that's not very good. But the key point is you can see where I'm going. Then it tells us I have a maximum demand of 10,000 for each product. So that's another constraint here. There's 10,000. And I have 10,000 somewhere here. But these are so far apart. So my feasible area is always going to be sort of here. So what does that now mean? So that means that this is my, as my ISO curve moves outwards, it will hit this point over here. So it's where these two lines meet. So really I need to simultaneously solve for one of them. It wants A, so why not just simultaneously solve for A? So let me try and get rid of B. So to get rid of B, I need the coefficients of B to look the same. And here I have 2, I don't have here. So what might be a good idea would just be to multiply this equation by 2. So my new equations will look like this, which is material X, A plus 2B, if you like, is equal to 8,000. And 4A plus 2B is equal to 16,000. Well, this is the bigger equation, isn't it? So I will subtract this equation from here. So 4A minus A is 3A. 2B minus 2B is 0. So that means that I now am left with 3A. 26,000, this 26,000 minus 8,000 is equal to 18,000, leaving me that A is equal to 18,000 divided by 3, which is equal to 6,000. So my answer here becomes C. Let me just see how many I have left to the end of this. Okay, yes, why not? Let us carry on and finish off. So it says the organization has this linear programming model. So these are all constraints, and it says that what is the maximum number of products of B that can be produced? Well, I mean, this is the key constraint. This is totally irrelevant. These two are relevant. You can't get here. You already have this constraint here. So therefore, for either of them, you can only produce a max of 60 on each side. So that's nice and neat. So it's just really, the constraint stops you from producing. Just tells you the maximum. So the answer there is 60. It says here the organization here, let's look at this, has created the following linear programming to solve this, to represent this situation. Has created the following linear programming to represent the position it faces currently in the presence of a short-term scarce resource. So let's look at the situation. So we have just found out that this is the point that produces the optimal point, right? So we can see here that we have this curve is the curve for hours. So that's the issue here. Hours here and demand for, because I suspect this is a demand curve. This is that there's only a demand for 500. I suspect that's what's going on here, of course. Now, obviously, everything else there's abundance of. We're only restricted by hours. You can see it here. That's that curve, hours, the hours curve. So the question says, which of the following has a shadow price? So to have a shadow price, I mean, it means you're restricted, right? So which of them has a shadow price greater than 0? Well, there's no point buying anything else because you have enough of it. So there's no point buying material B or material A. The only thing that definitely will have a shadow price greater than 0 would, of course, be direct labor hours, because that's where the restriction is. The restriction shadow prices are always only to do with scenarios where there isn't enough of a product. So here it's direct labor hours, and that's your answer there, direct labor hours. Okay, great stuff, and that's the end of the questions for limiting factors.